Welcome to Math in a Box with Susan Johnsey. In this lesson we are going to solve word problems, but first we must write a polynomial equation, factor it, and then solve it. There are three types of problems that we are going to consider: area of rectangles, single integer problems, and two consecutive integer problems. Let's look at the rectangles first. The length of a rectangle is 8 more than its width. Its area is 240 feet square. Write an equation for its area letting W be its width, then solve the equation for W and also find the length. Now, the sentence that says its area is 240 feet squared tells us quite a bit. We know the area of a rectangle is found by multiplying the length and the width. Area equal length times width. In this problem we are given the fact that the area is 240 feet square. So I can replace the area with 240. Let's look at the rectangle and the first sentence. The length of a rectangle is 8 more than the width. My usual rule of thumb is to let my variable be the smaller item. In this, it's the width. The width is what I will call W. The length of the rectangle is 8 more, so I will call the length of the rectangle W plus 8. Now that we know the length and the width, we can write these in our equation. 240 equals W plus 8 times W, the width. Let's go ahead and multiply these out. We have 240 equals W squared plus 8W. Now as you look at this, you'll see that you have three terms, and notice that we have a W squared. Hopefully this will remind you of what we call a trinomial, a quadratic trinomial. We need to move the 240 over to the right side so that we have 0 on the left. Of course, now when we do that, that will mean that the 240 is going to be negative. So we have W squared plus 8W minus 240 as our quadratic polynomial. Do you remember how to factor? We studied this in a prior lesson. The way I explain it is by using this box. Now you may have learned it a different way, which is quite alright. We're going to factor this into two binomials. We also discussed in a prior lesson why we need the 0. Now my 0 is on the left side. It can be on the right side. It doesn't really matter which side, but the 0 must be present in the problem. This is explained though in a prior lesson. Let's begin to factor. The F here stands for first. The first term will always be your term here that's squared. That's W. So W times another W gives us W squared. The L stands for the last. The last term is the negative 240. Now notice that this is a negative 240. In order to get a negative, we would have to multiply by one positive and one negative. Now usually that little blank is where I'll write that to help me remember that I have to have one positive and one negative. Alright, now what though we'll multiply to give 240? We could write 1 times 240. I doubt that's the answer though. Those are going to give us very large numbers. We could try 3 times 40. Of course, one of those has to be negative. Or we could use 3 and negative 40. Do you have an idea? Well, I think the numbers that we need are going to be a little closer together. Let's try 20 times negative 12. Now hopefully you already know how to do this. This is why I'm going very quickly over the factoring. This has been studied in several other lessons prior to this one. If I put 20 plus 20 in one box and a negative 12 in the other, we have our negative 240. Now we go across and multiply again. That's going to give you a positive 20W. And if I multiply going across this way, that's our fourth multiply we've done. That will be negative 12W. And when you add these together, you will get 8W. And that is our middle term here. All four multiplies have to be done, and then we add these two terms. If that gives you the middle term, you have it correct. Here are the binomials. W plus 20 and W minus 12. Now by the zero principle of factors, we know that the W plus 20 could equal 0, or the W minus 12 could equal 0. This gives us two baby algebra problems to solve. This one says that W equals negative 20. This one says W equals 12. Now remember, W was the width of our rectangle. Can the width of a rectangle be a negative 20? No. So this one's not possible. The answer to our problem is that the width is 12. The width is 12, and remember that the length was 8 more than that, so the length is 20. 20 times 12 is 240, the area of the rectangle that we wanted to know the dimensions for. You may want to stop the video now and make sure that you have written everything down.